Yeah. Hi everyone. Welcome to YourPedia. So let me know whether I'm audible or not. I think I'm audible. I think I'm audible. Yes. Just let me know everything is fine or not. Yes. I think everything is fine. Right. So we are going to start with network analysis for HPCL. Network analysis for HPCL. Yes. Yeah. Please confirm my audibility, please. Any one of you can confirm my audibility. So, few points before I proceed further. So those points are in HPCL from network analysis. Yes, from the topic network analysis, in from the subject network analysis in the examination HPCL, at least 10 questions will be given. At least 10 questions. See, this is a breakup. Okay. See, so our subject is network analysis. Network analysis. Okay, network analysis. So from this network analysis topic, at least for HPCL I'm talking about, for HPCL I'm talking about, at least 10 questions will be given and 10 marks. So one of the easiest topic, and the questions are also very easy, ma. The questions are also very easy questions. Means I can say within no time you will be able to answer those questions if you have the conceptual clarity. Okay, what are the important topics or what are all the topics we have to learn for this HPCL examination, for electrical examination from the subject network analysis is that is first one is DC circuits. DC circuits. So in this itself, I'm going to discuss what is node, what is mesh, what is super node, what is super mesh, how many number of equations are required to solve one network, what is the relationship between number of loops, number of branches, and number of nodes. All these things. See, the last one I told, that is the relationship between number of loops, number of nodes, and number of branches. On that formula itself, for all in all three papers, 2021, 2022, 2023, in all three papers at least one question is given. And sometimes they given to count the number of nodes. In nodes, simple nodes are different, principal nodes are different, reference is different, right? Principal node means more than two branches are connected at a point, that is principal node. Simple node, any two branches are connected, that is called as simple node, right? So having the idea of all these things is very important. Having the idea of all these things is very important, right? So first one is DC circuits. First one is DC circuits. The second topic is DC theorems. DC theorems. DC theorems. So third one is AC analysis. AC analysis. AC analysis. So fourth one is I can say I won't say exactly transient analysis. I won't say exactly transient analysis. What are the basics of inductor, capacitor, energy stored in inductor and energy stored in capacitor? These things are very important. Okay, so please guys, if you have any query, you can message in the chat box. I'm going to take up some questions. So my series is concept through questions. First I'll discuss some concept, and after that I'm going to discuss some questions. So AC analysis, and after that transient analysis. Not exactly transient analysis, as I told, very basic things in transient analysis. Means in the transient analysis itself, I'm going to discuss about inductor, capacitor, okay, small simple RC circuit, all these things I'm going to discuss in transient analysis. After that, magnetic circuits. Yes, from this topic, definitely one question on the coupling factor K and about self inductance, mutual inductance. On these topics, definitely one question on this topic, that is magnetic circuits, right? And the next topic is, I can say, three-phase circuits. Yes, and this is also important, that is two-port networks. Yes, two-port networks. So two-port network is very easy. Two-port networks. So that fellow will ask about the Y parameters or Z parameters or ABCD parameters. So this kind of questions will be asked. So the very important topic means out of 10, at least 3 to 4 questions will come from the first topic, that is DC circuits. Yes, out of 10, at least 3 to 4 questions will come from DC circuits. If possible, sometimes they will give you 5 questions from the topic DC circuits. Yes, any queries if you have, you can message in the chat box. Okay, I'll be resolving all your queries. So if you have any language barrier, I can speak Hindi also. You can ask question in Hindi also. If you want me to speak in Hindi, I'll speak in Hindi also. No issues at all for me, right? So now let's enter into the first topic. Let's enter into the first topic, that is DC circuits. That is DC circuits. In DC circuits, yes, in DC circuits, see, very basic onwards I'm going to teach. Very basic onwards I'm going to teach. That is DC circuits. DC circuits, right? So you all are electrical engineers. You all are electrical engineers. You know what does it mean by current, what does it mean by voltage and all. So I'm not going into the definition details of current and voltage. Yes, I'm not going to the into the definition details, like the rate at which charge is flowing is called as current. If you want, what is current? I is equal to dq by dt, the rate at which charge is flowing through any cross section. If you take some cross section, the rate at which the charge is flowing through the cross section is taken as current, and its units are either coulomb per second or amperes, right? What is voltage? What is voltage? Yes, the work done in bringing unit charge. The work done in bringing unit charge is called as voltage, right? But for a resistance, its units are either volts or joules per coulomb. Yes, joules per coulomb. Work done is in joules and charge is in coulombs, right? See, maybe questions can be asked on this kind of formulas also. So what we do is, after learning a lot of electrical engineering, we forget the basics like these things what we learned in our plus 2 level, plus 1 or plus 2 level, right? So please do not forget, these kind of formulas are also very important, right? Now, what is KCL? KCL is or before I go for KCL, let me teach you about Ohm's law. Yes, Ohm's law. What Ohm's law says? What Ohm's law says? Yes, current through any resistance. I'm taking resistance. You know, resistance units are ohms. You all are electrical engineers. That's why I'm not going into the in-depth details of what is resistance, what is inductance, and what is capacitance, what is susceptance. These things you all know these things very well, right? So resistance. If I apply some voltage, definitely some amount of current is going to flow through the resistance. Resistance is opposition for the flow of current. Resistance is opposition for the flow of current. So what Ohm's law says is, current through any element is directly proportional to the voltage applied, and the current through the element is inversely proportional to the resistance. Now, if I combine these two relationships, that is I is equal to V by R, or simply V is equal to I into R, or I can say R is equal to V by I. All these three relationships convey the same. All those three relationships convey the same. Don't worry. Some people may be thinking, sir, why you are discussing these small basics? Questions will be asked on these small basics only. Okay, we are going to see some questions after this discussion. Just let me go through the basics. After that, I'm going to discuss the concepts through these questions. Right now, see, observe here. What is KCL? KCL is Kirchhoff's current law. KCL is originated from the law of conservation of charge. What it says is that sum of the currents entering is equal to sum of the currents leaving. The sum of currents entering at a node, the sum of currents, yes, currents entering at a node, is equal to, what is a node? Node is a junction. Yes, this, see, on the concept of node, on all three papers, 2021, 2022, 2023, in all three papers, one question is there. Okay, I'm going to take up one big structure in that. What are the number of nodes? What are the number of branches? What are the number of loops? What is the difference between loop and mesh? Right? So independent loop and dependent loop, all these things we're going to see. What KCL says is the sum of the currents entering a node is equal to sum of the currents leaving the node, leaving the node. Suppose if I'm taking this node is also called as junction. Node is also called as what? Junction or node. So there are some three currents coming like this. Or see, this is I1. I'll write this one as I2. I'll write this one as I3, and I'll write this one as I4. According to KCL, yes. Can you please tell me, according to KCL, what is the equation? That is, I1 is incoming. Yes, I3 is also incoming. That is equal to, the leaving currents are I2 plus I4. right? According to the definition of current, what is current? The rate at which charge is flowing. Therefore, what is that is dq1 by dt plus dq3 by dt is equal to dq2 by dt plus dq4 by dt, right? dq4 by dt. So from this one you get q1 plus q3 is equal to q2 plus q4. This is nothing but law of conservation of charge. What law of conservation of charge says, ma? Law of conservation of charge says that charge neither be created nor be destroyed. It flows from one place to another place, that's all. And where it started, again it has to end there only. Yes, current always flows in a closed path. Current always flows in a closed path. If there is no closed path, current is zero. That is due to law of conservation of charge. How much charge is leaving, the same amount of charge has to enter at the same device. Suppose if this is device X, how much charge is leaving from this one, the same charge has to enter here. That is due to law of conservation of charge, right? So this is about KCL. What KCL says is sum of the currents entry is equal to sum of the currents leaving. What is the difference between network and circuit? A network may or may not have a closed path. A circuit means it must have a closed path, right? A network may or may not have a closed path, right? But a circuit must have a closed path. I can say all circuits are networks, but all networks are not circuits, right? This is one simple thing. And again, one more thing that is important here is planar and non-planar networks or circuits. Planar and non-planar. What does it mean by planar and non-planar? Suppose I'm taking one diagram like this. One diagram like this. Let me take like this. Yeah, I'm taking this way. This is planar. This is planar. I'm able to draw on this plane. But what is non-planar, sir? What is non-planar? See, I want to connect. See, I will increase the structure. I'll increase the structure. See, I want to connect. Let me take one more node like this, one more branch like this, and one more node like this. See, if you are not in a position to draw, suppose, see here in this itself, I'm going to define the number of branches and number of loops and number of meshes, everything. So branch means every element is treated as a branch. Every element is treated as a branch. How many number of branches are there here? Yes, number of branches. Come on, number of, yes, branches is equal to how many are there? Number of branches is equal to B is equal to, this is the first branch, second branch, third branch, fourth branch, fifth branch, sixth, 7, 8. There are 9 branches. Number of branches are 9. Yes. So this way of counting is very, very, very important for your examination. The total number of branches are 9. Now, if you come here, how many number of nodes are there, sir? Total nodes, principal nodes, these things we will see. You see, if you see carefully, this is also a node, but here no current division is taking place. Current is not getting divided at that node. First of all, let's count from here. This is a node. Yes, this is a node. This is a node. I call this one as a node 1. I'm putting circle on the node. Okay, branches is normal numbers, and nodes I'm taking with the numbering with a circle on the number, right? That is 1. And this is a second node, right? This is a third node, right? And this is a fourth node, right? This is the fifth node, and this is going to be the node number 6. Total number of nodes, if anyone asks you how many total number of nodes are there, the total number of nodes are 6. But see, I'll write here total number of nodes are, see, from the given question you have to understand whether he's asking about total number of nodes or principal nodes. That depends on the given question, right? See here, total number of nodes are 6. Total number of nodes is equal to 6. One node is reference. One node is taken as a reference. Sir, you taken the down node as a reference. Yes, I taken this one. Can I take any other node as reference apart from this? Yes, you can take any other node. There is no rule that you have to take only this node as reference. Among the available nodes, you can take any node as reference, right? Principal nodes are how many? See, this is a simple node. This can be left, that can be left, and this is the reference node. Therefore, I can say there are 4 nodes. Okay. Yes, by excluding the reference, and this is a closed path. Yes, this is a closed path. First closed path, second closed path, third closed path, fourth closed path, fifth closed path. Those are the number of loops. Those are what? Number of loops. How many are there? 1. Yes, this is Roman numbers I'm taking. 1, 2, yes, 3, and this is 4, and this is 5, right? right? Yes, observe here. I'm going to give one relationship between number of loops and number of branches and number of nodes. That is L, total number of loops, is equal to B, total number of branches minus nodes plus 1. This relationship must satisfy for any given network. Yes, L is number of loops. Yes, please, if you have any query, type in the chat box. Chat box is available to me here. I will be able to read your query and I will answer your query, right? So the relationship between number of loops, branches and nodes is L is equal to B minus N plus 1. Let us check whether it is correct or not. Let us check whether it is correct or not. See, how many we got? Number of branches, how many we got? Number of branches, how many we got? 9 minus how many number of nodes are there? We take a number of nodes are how many? Total 6 nodes, but in that one simple node, one principal node, if I leave, how many? 4. 9 minus 4, how many? Yes, 9 minus 4. But here n stands for total nodes. N stands for total nodes. How many total nodes are there? Total nodes are 6, including reference. When you're taking in this formula, you have to take the total number of nodes, including simple node and reference. Yes, 9 minus 6 plus 1, that is equal to how much we are getting? 9 minus 6. Yes, that is 3 plus 1, that is 4 we are getting. Yes, number of number of loops, how many we got? Number of loops are 5. So yeah, I forgot to tell you one thing here. Yes, observe it carefully, or we'll come back to here after taking that. We'll come back to this formula. This formula must satisfy for any given network. This formula must and should satisfy. L is equal to B minus N plus 1. But the confusion part for the students here is, sir, when I'm taking nodes are, see, these are the nodes, total nodes, including reference. Okay, means including simple nodes, right? But simple nodes are not counted. Why? Because see, this is here, no current division is taking place. Come here, no current division is taking place. If you come here, what is current division? I will tell you what is current division. Some current is coming here, that is divided into 2 parts here. Some current is coming here, that is divided into 2 parts here. Some current is entering here, that is dividing into 3 parts in fact. Yes, some current is coming here. Yes, that is divided into 2 parts like this. But here some current is coming, the same current is flowing here. Therefore, this node is left. If we left that node, we have to take 9 minus 4 in fact. Yes, sorry, 9 minus 5 in fact I have to take 9 minus 5. Just a minute, just a minute. 9 minus 5 we have to take. Yes, 9 minus 5 plus 1. Yes, how much it is? 4 plus 1, it is 5 loops. Okay, the total number of loops are how many? 5 loops those are, right? So see, this is very simple. This is very simple. That formula is going to play a very important role. That formula is going to play a very important role, right? Next, before I enter into the questions, let me take a few more concepts. The resistance is connected in parallel, resistance is connected in series. Then we saw about KVL, KCL. Let's see KVL also first. Let us see KVL. What is KVL? Kirchhoff's voltage law. What it says? Sum of all the voltages. It may be a source voltage or it may be a voltage drop. It may be a source voltage, it may be a voltage drop. Sum of all the voltages in a closed path. Yes, in a closed path. Is equal to 0. And from where this KVL is originated? The KVL got originated from law of conservation of energy or power. See, KVL is originated from yes. After this one, I'm going to solve previous HPCL questions, and in those questions I'm going to explain you the concepts. KVL is originated from law of conservation of energy or power. Law of conservation of energy or power. So this is KVL, right? Now let's talk about series combination and parallel combination of resistances. This is the last explanation. After that, I'm going to enter into the questions. Yes, series combination. When some resistance are there in series, so this is R1, this is R2, and so on. If you have n resistances in series, then total resistance RT is equal to R1 plus R2 and so on Rn. Yes, and so on Rn, total resistance, if the resistance are in series. Very simple, you all know that. You all know that. For parallel, what this is the parallel connection, this is the parallel connection. If there are n number of resistances in parallel, you know what does it mean by parallel connection? If voltage is same across the connected elements, then those elements are said to be connected in parallel, right? Now R equivalent is equal to how much, ma? Yes, R, see, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Suppose if it is having n resistances and so on up to 1 by Rn, 1 by R2 plus 1 by R3 plus 1 by R4 and so on up to 1 by Rn. This is a parallel combination of resistances. If there are two resistances in parallel, if you want R equivalent, take the reciprocal of this one, right? Take the reciprocal of that one. Let us enter into the previously asked HPCL questions from this network analysis 2021, 2022 and 2023. Let us discuss please. Yes, very good question. Very good question. The very first question, read the question carefully. A 9 volts battery supplies 1 milliampere current in series circuit of 3 resistors R1, R2, R3. Just now itself we discussed the series connection. Yeah, what that fellow says is there are 3 resistances connected in series R1, R2 and R3, right? R1, R2, R3. What is the battery that fellow connected? He connected 9 volts battery. Yes, 9 volts battery. And how much is the current that is flowing? 1 milliampere of current is flowing. If the voltage drop across R1, R2, R3 is 1 volt, voltage drop across R1 is how much it is? 1 volt, and across R2 is 2 volt, across R3 is 6 volts. Okay, fine. Find the values of R1, R2 and R3. So he's asking how much is R1, how much is R2, how much is R3, right? But before I go for that one, let me get that total resistance first of all. Total resistance. What is total resistance? Total resistance is equal to total voltage by total current. Yes, total resistance by total current. Then for total resistance is equal to how much, ma? 9 kilo ohms. So options must satisfy this total resistance. What is total resistance in series? R1 plus R2 plus R3. Yes, must be equal to 9 kilo ohms. So see which of the options are going to satisfy. More than one option will satisfy for that one. And one more thing, what is the voltage drop formula? I is equal to V into R. Sorry, I wrote wrong. Voltage drop V is equal to I into R. Means voltage across, see, I'll say V1 I call. This one is V1, this one is V2, this one is V3, right? According to KVL, yes, according to KVL, diagram missed. Just a minute, ma. Diagram will come back. Yes. Just a minute. Yeah, diagram came back. Come here. So this is wrong. I wrote wrong. So V is equal to I into R. Okay. Now come here. V is equal to I into R. Let me take a new page here. I want some good space. Come here. This is the next question. So total voltage. Yeah. Total voltage V is equal to V1 plus V2 plus V3. Right. And this is 9 volt. V1 is equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. Now, I is same. Why? Because series circuit, I is same through all the elements, series circuit, right? Now, it is going to be R1 plus R2 plus R3. So, what we have to understand is, we know that voltage drop is directly proportional to resistance from this relationship, or from this relationship. So see, more is the resistance. If more is the resistance, more will be the voltage drop. Let's come back now. Here this is having more voltage drop, therefore R3 should be more. This is having more voltage drop, therefore R2 will be in the middle. This is having less voltage drop, R1, right? So from this relationship I can write R3 must be greater than R2 must be greater than R1. And another relationship is R1 plus R2 plus R3 is equal to 9 kilo ohm. Tell me which of the following options are satisfying. Yes, answer please. Yes, you can answer in the chat box, ma. Answer please. Which of the following options are satisfying the given question? See, 1, 2, 6. 1 plus 2 plus 6, 9. Option A is satisfying both. 6 to 1, no, I want R3 should be more. 2 3 4, fine. 2 3 4, it is fine, but 2 plus 3 5, 5 plus 4 is 9. Yes, one, see what is that drop he given? 1 volt, 2 volt, 6 volt. 1 volt, 2 volt, 6 volt. Yes, we want total should be 9. So 2 plus 3, 5, 5 plus 4 is 9. And we want R4, R3 must be greater than R2, must be greater than R1. Means R3 should be the highest value. Option C is also satisfying. Let's see among A and C. Let's decide. Yeah. Next, 4, 2, 3. This is wrong. So two options are satisfying here. Two options are satisfying here. Now tell me, two options are satisfying. Among those two, A and C, which one is correct? Yes, yes. I want your answer in the chat box. Among A and C, which one is satisfying? See, good question it is. If I send 1 milliampere of current, if I send 1 milliampere of current, yes, 1 milliampere, how much it is? 2 plus 3, 5 volt. 5 plus 4, it is 5 plus 4, 9 volt. Here also 1 plus 2, yes, 1 plus 2, how much it is? 3. 3 plus 6, it is 9. Either A or C, both are correct. Either A or C, both are correct. There is, see, but because I'll tell you here, either A or C, both are correct. You see, I is equal to V9 by R1. Yes, how much is R1? R1 is 1, R2 is 2, R3 is 6. So 9 by, yes, how much it is? All these are in kilo ohms. All these are in kilo ohms. How much it is? 6 plus 2, 8, 9 kilo. Therefore, it will be 1 milliampere. And we got R3 greater than R2 greater than R1. But here, one thing we forgot that voltage drops are not matching. Therefore, C is not correct. Yes, I didn't saw that. Voltage drops are not matching. What are the voltage drops? What are the voltage drops? 1 volt, 2 volt, 6 volt. 1 volt, 2 volt, 6 volt, right? Sorry, I forgot to see this one. 1 volt, 2 volt, 6 volt. If 1 milliampere of current is flowing, does this 2 kilo ohms will give 1 volt? No. 2 kilo ohm into 1 milliampere will be 2 volt. Yeah, this is going to be 2 volt. This is going to be 3 volt. This is going to be 4 volt. This is going to be 1 volt. This is going to be 2 volt. This is going to be 6 volt. So voltages are voltages, current, and the relationship between the resistances and the total resistance all are matching in option A. So option A is perfectly correct. Option C is not correct. Yes, due to my overlook, I didn't saw this 1 volt, 2 volt, 6 volt, and I didn't compare here. Voltage also should match. Voltage also should match, right? Option A. So very good question. So it is looking simple. Yes, it is really simple, but it will take some time to inspect the options. Why? Because you can't get with the equations R1, R2, R3 values. You have to check the options, right? Next question, please. Next question. Yeah. What is the next question? Yeah, as I told you, there will be definitely one question. There will be definitely one question on the relationship between loops, branches, nodes, and nodes. These three things, right? What is saying? A simple coplanar network. There are 7 branches. Okay, number of branches is equal to 7, and 4 nodes. Sorry, this is 7. And number of nodes is equal to 4. How many mesh currents are required for the solution of this network? So simply L is equal to B minus N plus 1. So number of meshes, L is nothing but number of meshes. 7 minus 4 plus 1. 7 minus 4 is 3. 3 plus 1 is 4. Answer is 4. Option is 3. Option is 3. Very good question, and it is a simple question, right? Next question, please. Next question. Yeah. Find R equivalent in the given circuit. These are not my own questions. These are previously asked questions in the HPCL examination. That's why I discussed the same concepts which were asked previously, related to this one, right? Come here. What is asking? Find R equivalent in the circuit. Yeah, you are here. Always you stand here. From where he is asking. Go and stand there. Go and stand there. Yes, we are here. If we see from here, I can say this 52 and 28 both are in series, and this is a simple load. This is a simple load, right? Same current is flowing. If 2 resistances are in series, those 2 will be directly added. Now I'm drawing the same diagram. This is 15 ohm, yes, and this is 20 ohm, and this is 25 ohm, right? And 52 plus 28, 50 plus 20, 70. 70 plus 10, 80. Yes, this is 80 ohm, right? This is A, this is B, this is A, this is B. And 20 is in parallel with 80. 20 is in parallel with 80. I told you, if there are two resistances in parallel or n resistance in parallel, 1 by R equal to is equal to 1 by R1 plus 1 by R2 plus 1 by Rn. Here two resistance are in parallel. Then these two can be mentioned as single resistance. What is that value? 80 into 20 by 80 plus 20 is 100. 0 0 gone, 0 0 gone. How much it is? 16 ohms. Now that can be redrawn as 15, and this is replaced as a 16, and this is already that fellow given 25 ohms. This is A, this is B, and we are here. If you see from here, 15 plus 16 plus 25, all three are in series. 25 plus 15, how much it is? 30. 40 plus 16 is R equivalent is equal to 56 ohms. R equivalent is equal to how much? 56 ohms, right? That much easy it is. Option it is 3. Next question, please. A mesh cannot be defined for dash network cope. See, it is for non-planar network. Non-planar network means you are not in a position, or we are not in a position to draw on a plane, on a 2D plane. That is a non-planar network. For non-planar network, we cannot write mesh equations. But for non-planar networks, we can write KCL equations. I'll write here. That is, for non-planar networks, mesh equation cannot be written. See, what is that? For non-planar network. See, a note point here. This may be asked in the next upcoming HPCL examination. Okay. See, but for non-planar network, networks, KCL can be written. Yes, KCL we can write happily. KCL we can write happily for non-planar networks, right? Next question, please. Next question. Find the current I in the given circuit. You know, this is one of the simplest question. Use Ohm's law. Previously given question in HPCL examination. So don't think that, sir, you're teaching very simple things or small things. This is the question previously given in HPCL paper. In 2022 paper, this question is given. You can check. Okay. See, I taken the question as it is. You can see the options also. 1, 2, 3. 1, 2, 3. See, this is the question directly taken from HPCL paper. Observe, what is current? Current is equal to voltage divided by resistance. But current is equal to how much is the voltage? 12. But all three resistances are in series. Yes, all three resistances are in series. Yes or not? All three resistance are in series. How much it is? In series means resistance will be directly added. How much it is? 100 plus 400 plus 300. How much it is? 800 it is. That's all. 800. So how much it is? 12 by 800. So for 3 cities, for 2 cities, 3 by 200. How much it is? 1.5 by 100. So therefore it is 0. For 0.15 amperes. So current is 0.015 amperes. Option is 1. That much simple it is. You see, if that fellow asks about some very good questions from transient analysis, yes, we are here. We can teach you that level. But that fellow in HPCL is asking very simple question. Here you can verify that L is equal to B minus N plus 1 relationship. How many loops are possible? Only one loop. This should be 1. How many branches are there? 1, 2, 3, 4 branches are there. 4 branches are there. Then what are the nodes? See, previously, previously, you see, this is 1, this is 2, this is 3. This is the reference, right? 1, 2, 3. Yes or not? So here it is simple. I can say one loop, only one loop. L is equal to number of loops or number of meshes is equal to B minus 1. How many branches? 1, 2, 3, 4. 4 branches are there. 4 branches. So here number of nodes 1, 2, 3, 4. This is also. So 4 minus 4 plus 1. So 1 is equal to 1. 1 is equal to 1. Right? See, it is a one loop. I can say network. One loop network. That's why I taken all the nodes. Right? Let's go for the next question, please. What that fellow says: determine the voltages at the node A and node B in the given network. So he's asking the voltage here at node A and node B. This is A, this is B. This is A, this is B, right? At A and B, that fellow is asking the voltages, right? Observe here carefully. How to find voltage at a point? See, voltage at a point is found by by writing either KVL or KCL. In some way you can find, but here very easily we are going to find. But reference is always 0 volts. If you want voltage at a point, from that point you go to ground. See, I want VA. First of all, tell me, this is 3 amperes. That 3 amperes is coming. This is 1 ampere. According to KCL, all that 4 amperes is going here. No, all that 4 amperes is going here. If 4 amperes is going here, what is the voltage here? Plus minus 4 twos is 8 volts. 4 twos is 8 volts, right? 4 twos is 8. Now here, you see again in this one 3 amperes is going, and that remaining 1 ampere is coming here, and this is how much? Plus minus how much it is? 1 volt. Now you start here, go to ground. Sorry, it is 3 volts. Sorry, 1 ampere. Current is 1 ampere. As a resistance is 3 volts it is. You start at A and go to ground. If you start at A, go to ground, how much is the voltage? VA is 3 volts. Simply VA is 3 volts, right? Now come to B. He is asking about B. So can you go like this to the ground? No. Can you go like this to the ground? No, because those are voltage sources. Therefore, I'm following this way. So VB is equal to 8 plus 3, that is equal to 11 volts. 3 volts and 11 volts is the answer. 3 volts and 11 volts is the answer, right? Let's go to the next question. Two equal resistors of 10 ohms each are connected in series with 20 volts. Okay, that fellow says two equal resistances 10 ohms and 10 ohms connected in series with 20 volts. In series with 20 volts DC supply. Find the current through each resistance. So two equal resistances of 10 ohm are connected in series with 20. Yeah, the current is 1 ampere simply. So current I is equal to 20 divided by 10 plus 10, that is equal to 1 ampere. That's not a big question at all. That is a question directly from Ohm's law. That much easy the question is. Next, yeah, this is also previously asked a question in the HPCL examination. Okay, I didn't remember in which year it is asked. Maybe in 2021 or 2022 or 2023. I didn't remember. Please, yeah, read it. What the fellow says: calculate the power absorbed by 9 kilo ohm resistor in the following network. 9 kilo ohm resistance. Yes, this is V0. 9 kilo ohm resistance. In this one, he is asking the power absorbed. So I want current in this one. First of all, apply current division. What is current division? With that current division rule, you are going to find how much current is flowing through which branch. So I'll take this one as I0. So I0 is equal to total current is how much? 30 milli into opposite resistance. 12 plus 16 is 12 plus 6 is 8 divided by total. How much it is? Total is this is 18 plus 9. 18 plus 9. Right, so I0 is equal to 30 milli into 18 divided by how much it will be? 27. So 9 2s, 9 3s, right? So 3 densities. So I0 is equal to 20 milliamperes. Then what is the power in a resistance? Power in a resistance P0, I write as I0 square into R. The resistance is 9 kilo ohm. Therefore 20 square means 400 into 10 to the power of minus 6 into 9 into 10 to the power of 3, that is equal to how much it is? 9 into 4, how much it is? 36. So 3600 3600 into 10 to the power of minus 3. Therefore it is simply 3.6 watts. 3.6 watts. Option is A. Right, that much easy it is. Next question. This is also previously asked HPCL examination question. Find the voltage at node B in the given circuit. I told you, if you want node voltage at any node, start at that node and go to ground. Following KVL sign convention. What is KVL sign convention? Current entering point is taken as positive, current leaving point is taken as negative. But where is node B? This is node B. From here to ground directly you can go like this. So if you see how much you're encountering, minus plus 12 volts. Therefore, VB is equal to minus 12 volts. Option is 3. VB is equal to how much? Minus 12 volts. That's a direct answer. It's a direct answer. So nothing to analyze there. Nothing to analyze over there, right? Next question, please. Find the current IM in the circuit. In the circuit, find the current IM. This current he is asking. As I told you, to apply current division, you see the arrow is down, but this IM is given down like this. This is IM. Now I'm writing current division. So IM is equal to minus of, why minus? If the arrow is up here, that current will flow like this, but current is flowing like this only. That fellow given this way to take, but this arrow is down, therefore minus into 5 into opposite resistance is 10 by total resistance is 10 plus 40, it is 50. So how much it is? Minus 1 ampere. Minus 1 ampere it is, not milliamperes. Minus 1 amperes. The option is 2. The option is 2, right? That much easy it is. Let's go to the next question, that is find current I in the given circuit. He is asking the current I in this one. He is asking the current I in this one. Now, if you observe, if you want the current in this one, first of all, we must want the current from here, total current. These two are in series. How much it is? 600 plus 150 is 750. 750 is in parallel with 500. So 750 in parallel with the 500 means 750 into 500 by, so 750 plus 500. How much it is? 750 into 500 divided by 700 plus 500. How much it is? 7 plus 3000. 1250 it is. 1250. So 0 gone. Yes, 50 or 25 two cities, 25. Now it is 5s, right? 25 5s. Yeah, 25 4s is 100. 25 5s is 125. So 7, that is equal to 750 into 2 by 5. So how much it is? 5 ones. 2 is left here. 5 5s, 0. So it is going to be 300. It is 300 ohms. So this total will be replaced with 300. That 300 is in series with 200. Therefore, total current I is equal to 40 divided by 500. But I want the current small I. Small I is equal to capital I. What is that? 40 divided by 500 into 40 divided by 500 into opposite resistance. So this resistance 500 divided by total, how much it is? 750 plus 500. 750 plus 500. Yes, if you solve it, you're going to get the value. So here 40 divided by 500 is this total current. So I want this current. So this current is equal to total current into opposite impedance by total impedance, or opposite resistance by total resistance. 40 by 50 into 500 by 500 plus 750. 500 gone. So it is 40 divided by 1250. So it is 4 divided by 125. 4 divided by 125. That is 32 milliamperes. 32 milliamperes. See, all the questions are one-step or two-step questions, including the, I can say, simplification. That much easily that fellow given. So in the next paper also we can expect the questions of same level, not any higher level than this. Next, what is a super node? See, there is a node here. There is a resistance. There is a resistance. There is a resistance. This is a node or a junction. This is a node or junction. Suppose if I assume voltage as V here, this one as R1, this one as R2, this one as R3. I can write KCL here. That is all the currents I'll assume that leaving. It's here up to you how you are assuming. That just after it is an assumption, you can assume that all the currents are leaving, or all the currents are entering, or some of them are entering, or some of them are leaving. That is up to you, right? So I am writing KCL. What is that? V by R3 plus V by R2 plus V by R1 is equal to 0. So this is KCL. But this provision is not there if you have some voltage source like this between two nodes. Yes, there is a resistance here, there is a resistance here. You cannot write, see, this one is V1, this one is V2. You can't write V1 minus V2 by 10. Why? Because this itself is voltage, not resistance. So if there is a voltage source between two nodes, this is node A, this is node B. Between two nodes, if there is a voltage source, that node, those two nodes commonly taken as I can say super node. Taken as super node. Directly you cannot write KCL over there, right? That's the concept of super node if there is a voltage source. Then what is super mesh? Super mesh means yeah. See, super instead of see super mesh. I'm changing the question. Is considered when there is a yes current source, when there is a current source between two meshes, between two meshes. Next, it's a counter question. It's counter question. Super mesh, right? Let's go to the next question. Find Vm in the given circuit. Is asking what is the Vm in the given circuit. Just apply voltage division. Vm is equal to, see, it is a single loop circuit. Vm is equal to 8 into 25 by 25 plus 75. So Vm is equal to 8 into 25 divided by 100. 25 fours it is, so 4 twos it is, simply it is 2 volts. Answer is 2 volts it is, please. Answer is 2 volt, right? So these are all the previously asked questions from the topic DC circuits from the subject network analysis. Okay, I didn't cover all the questions. There are few more questions which are left. We are going to see those questions in our live classes on panel, on YourPedia panel. See, if you want this PDF, please message me on WhatsApp to this number, right? Message me on WhatsApp to this number, right? So 89199999705. So I'm the faculty who is going to take this network analysis and power system electrical engineering classes. So I'll clarify what are all the doubts if you have, right? If you have any doubts, you can call to that number. So here, one point before I wind up today's session, I want to tell you is the asked questions in HPCL examination from any subject are damn easy. Just it is that you have to cover all the topics in a very clear manner. I mean, the conceptual clarity is very, very important. Okay, fine. We'll meet in the next session. This session continues. We'll meet in the next session. Thank you.